So you would have gotten your CVS file exported from your graphical analysis, and you can open it in Google Sheets or Excel or whatever you're using. So what you have to do here, you will have a lot of these type of column with the time. Like every conductivity column will come with the time column. I just remove them. You don't have to, because you're not going to present this data to me. But I just remove them so that my columns are closer together, the ones I'm going to use. The other thing is, for some of your trials, you may have collected beyond 20 seconds. So if you did, you just highlight all those columns and delete them, remove them from your data. Okay. So the first thing that I had to do was, we have a lot of data here for one trial. Okay, it's about the same, but it's different, and there's a lot of it. What do you choose? What I did was, I decided that I was going to use the average value. So I calculated average using spreadsheet, equal, average, and then I highlighted the cells that have the values that I want to average. Okay, and then to get uncertainty, it would be not representative for me to say it's plus or minus the smallest readable unit, because if you look at the decimals there, I think there are 7 of them. So saying that plus or minus 0.0000007 would be an underestimation of the uncertainty. So what I used was another method called the max minus min over 2. And in this way, I just find the maximum value and the minimum value, subtract them from each other, and then divide by 2. And on spreadsheet, you can do that by determining the max value. You don't have to actually go and find it. You can use spreadsheets like equal max and then highlight all the cells, and then same thing, equal mean, and highlight all the cells, and then do a max minus mean divided by 2, and then just drag across so that you don't have to do too much work. Alternatively, you could just do the whole formula in one without having to do separate rows. Okay, I did that because I wanted to show that you could do it. Okay, but if you do it all at once, as you can see the formula up top, it's equal max, and then you highlight minus min, you highlight, divided by 2, and you get the same value. And you can drag that across as well. I didn't, but you could. You should when you do this. Okay, so now I have my trial data. The average here is trial 1 data, and this is its uncertainty over here. This is trial 2, this is its uncertainty. So the work that I expect to see in your lab report is this: trial and uncertainty, trial and uncertainty, and so on and so forth. So I have mine here. This is for distilled water. This is for 20%, 40%, 60%, 80%, and 100%. Okay, and then I have the other trials. And then for the uncertainty, I also put the values in this table. Okay, so then something else that I needed to do was determine the uncertainty of the concentration of Ki. And to do that, remember when you made the solution, you started by weighing the salt. So there was measurement uncertainty there, and then you made it into a solution, measurement uncertainty there, and then you did dilution, measurement uncertainty there for the first value, and then again the other value in your dilution. So for instance, for 80%, you put 16 mils of the Ki solution, so that will be uncertainty of 16 mils, and then you also put 4 mils of water, so there will be uncertainty for the 4 mils of water. Okay, and then you can just add them up here. I believe I missed one uncertainty here, which I will add and then modify my calculation. I missed the volume uncertainty for the volumetric flask because I didn't search it yet, but I will just add it here inside this big bracket here. Okay, so then the next thing was, I have the uncertainty for the concentration, I have the uncertainty for the conductivity, and I have the actual values. So I just did averages. Average of conductivity, same way we usually do average, equal average, and then you get the 3 trials. And then for the uncertainty, I also did an average of the uncertainty. Okay, I also did an average of the uncertainty. I think that simplifies the work. You have to explain below that to get the uncertainty of the average. You just took the average of the 3 uncertainty values. Okay, and then I also had the uncertainty for the KI, which I had calculated up here. So with those values, now you can go on to LogaPro. Okay, I'm not sure whether LogaPro is going to appear here, but if it does, good. Okay, so in LogaPro, remember last time I showed you guys how to add new columns, and I added new columns. One of the columns I added was for uncertainty of concentration, the other one was the uncertainty of conductivity, and then I had my original. On the x-axis I have concentration, and on the y-axis I have conductivity. With that information I plotted, and I got the error bars. If you see my error bars here, I hope this shows. The error bars, the vertical ones, are very tiny, so it looks like they are not there, but if you look closely they are actually there, and the ones for concentration are much larger. Okay, so this is how you'd process the data. Remember, for everything that we've done here, you have to show a sample calculation. Okay, so just choose one value and show how you did all the calculations in your lab report. Thank you.